Hello, welcome to the webinar Minutes Not Months. We're here today to talk about what we're doing with cloud native architectures. There's going to be two speakers today, Wade Schools, who's the VP of Engineering at Digicert, and myself, Brian Trupeck. I'm the Senior Vice President of Product. Wade, do you want to give yourself a little introduction and some background?
My name is Wade Schools, Vice President of Engineering for Digicert over our emerging markets team. I manage the design and installation and setup of our Pki solutions, such as Digicert One.
Thanks, Wade. I'm Brian Trupeck, like I said, and as Senior Vice President of Product, I manage the global product lines for Digicert, including everything in our public TLS product set, our emerging market product set, IoT, document signing, all of the components that we do as Digicert. And so today, what we're really going to talk about is the journey that Wade and I went down with the transformation of our organization around pursuing a cloud native architecture for our Pki systems, and really just kind of talking about some of the lessons learned, some of the things we ran into, the cultural change, and everything that kind of came along with it to get us to the point of being able to come out on the other end of it and release products and services to the world. So with that as an intro, what we really want to kind of talk about at the beginning is Pki. So public key infrastructure. It's at the core of everything that Digicert does. And the core of this story is really rebuilding a system and looking at how to architect this for the future. If you're new here and you need a little refresher on what Pki is, you came here maybe for the DevOps conversation, that's fine. From a Pki perspective, we kind of boil that down into validation components, being able to say that the entity, person, or device that's enrolling is actually the thing that should be and is allowed to. Registration, so the activities behind that validation of being able to do those assurances. And sometimes those are people processes, sometimes those are automated processes. On the public TLS side, there's a combination of those things. For IoT devices, there's maybe other on-ramps into that. And then issuance, so the actual action of creating a certificate and getting it to whoever's registered to use it. A lot of people think of that as the action of a CA. There's obviously quite a bit more to it. And then all of these things are really based on cryptography, right? So the validation, the integrity of those certs, the registration, issuance, there's crypto underneath there. It's been long-standing for many years, very tested, very fail-safe. That's why Pki is so valuable and at the core of all transactions and everything that's happening on the internet. So that's kind of the characteristics of the system, a Pki system that we have, and we'll kind of talk about that a little bit more. And we're going to talk about the journey that we went on from really bringing this to the cloud and getting a cloud native architecture, doing that within the confines of a Pki system where, by doing Pki, there's some dependencies, there's compliance things, there's regulatory things that need to be addressed that, maybe seem kind of at odds with very dynamic deployments, but we had to figure some things out we'll talk about. And then the cultural shifts. What does it look like as an organization to move to DevOps and move to CI/CD and embrace cloud native architectures and how those systems get deployed. There's a lot of things that we ran into between Wade and myself in trying to figure those things out with our organization. So let's talk about our customers. This is kind of where our journey begins as we went down this path of transformation for our products. How are our customers actually using Pki? We've broken this up into kind of 4 segments, and we'll reference this throughout the presentation. But in the upper left quadrant here, we have managed, Digicert Managed Private Cloud, we'll call it. And those are systems where Digicert ourselves is managing the end-to-end system. We're managing the data centers, we're managing the security operations with the hardware security modules, the HSMs that store keys and crypto information. This is kind of the typical things people think of when they come to us for public trusted TLS certs, or they come for fully managed PKI that is private and working for enterprises for maybe user authentication and things like that. And we provide automation services around that so people can do things with the certs beyond just get them issued. That's very much one kind of customer and one kind of deployment, right? And that's really where we're like, an MSSP or a managed service. Somebody's just consuming us from some portal or some endpoint API. Moving to the lower left, we have government trusted, what we're calling Digicert Managed in-country installations. And this is, in these government trusted kind of electronic signature workflows would be demonstrable of this kind of customer. Folks are looking for Digicert to manage, just like we're talking about in the upper left quadrant, the full PKI experience, but they have the added kind of complexity that they want the keys, the key management, the private keys for this PKI system in a specific country or in a specific region. They want the data, maybe by law or regulation, in a specific region as well. And sometimes they may not be the same region. And they want potentially localized resources. So it wouldn't be acceptable to have the people validating somebody coming into the PKI system for maybe a passport to have them be a US citizen. They'd have to maybe be a citizen of the Netherlands because the system was for the Netherlands. Those kinds of systems are still managed by Digicert, but from a complexity perspective, now we have kind of more of a different deployment that needs to adhere to those kinds of rules and allow for those things to exist and do that across multiple jurisdictions, right? So it's not just go solve it for one country like the Netherlands. It's go do that for each country in Europe, maybe each country in Southeast Asia. And you can see how that becomes a problem to repeatably do that and manage that as an organization. So we'll talk about what that means for those customers. And then in the upper right corner, we have IoT supply chain and device provisioning kind of as the customer. But you can think of the deployment here, the deployment type, as customer managed in factory. And this is where customers are really looking for low latency. They're looking for the highest amount of uptime because they're attached to an assembly line. They can't interrupt that assembly line. They can't have something go down because they can't stop the process of manufacturing. And they're maybe also looking for that key and data sovereignty like we talked about in the lower left quadrant. Depending on what they're manufacturing, how it's being used, they may want to manage those things too. And so in this environment, it's very interesting because now somebody's looking to take this kind of PKI system, deploy it in a factory, and maybe even air gap because the factory doesn't have connection to the outside world or the assembly line doesn't have connection. That provides a whole different set of kind of challenges for how we build these systems. And Wade will be talking about some of this a little later. The last one is government programs. So we call this deployment type kind of customer managed in country. And in this, it doesn't necessarily even have to be governments all the time. So it could be enterprises that have these kinds of concerns, but I think governments, paint the picture of the requirements the best, that they're maybe the highest security. They want to make sure that the data, the keys, no processes, no systems are outside of their line of sight, their control. Key sovereignty, data sovereignty, of course, they want to make sure that stuff is under their control, and potentially nationalized resources here again. But in this situation, as contrasted with the lower left, they absolutely want to fully control this deployment, and they don't want Digicert as any part of that deployment because they want the highest security around all of those components. So these four kinds of deployment types really kind of summarize what our customers have been asking us for and how we're trying to address that market. And as you can see, it creates some complexity for us and kind of why we're getting into this conversation. So to address these kinds of customers in the past, we've kind of traditionally provided managed PKI, like I talked about, that upper left quadrant, where we're hosting, managing, doing all that. But obviously that doesn't fit into the other three quadrants, right? So customers would have some challenges with us. We couldn't, actually engage in some of those markets meaningfully a lot of times because we just couldn't do those things as a managed service. Also, in the acquisition of the semantic business with Digicert, we did get some on-premise PKI solution software, came through the VeriSign semantic lineage. As we looked at that to provide solutions for those other three quadrants, we saw that it was amazingly costly and time-consuming, really kind of difficult to maintain and scale, both for us and for our customers. it wasn't the best solution, we felt. You look at it, the complexity, I think, is manifested in the fact that there was 57 separate PDF manuals and installation documents to configure this system. So it's very manual deployment, kind of traditional procure servers, stand them up, configure load balancers and networks, and then do all of that work another 3 times to get HA and test. And then once you've done that, you've kind of fixed the system as far as what its capacity is. So when your deployment grows, it was very difficult to catch that environment up and grow your deployment to reach capacities, especially for IoT type customers where those capacities can be very dynamic. So these were kind of our challenges with the solutions of the past. And again, kind of kicked us in the path to say, we need to rethink what we're doing here. And this got us down to this cloud native solution. So as we explore what we're doing with our cloud native solution, which is called Digicert One, that's the security platform architecture. We have different managers on that solution. Let's kind of compare and contrast that with a traditional deployment. You can see here the criteria on the left is maybe what you'd think of as a traditional deployment, certainly what our customers did in trying to put some of these solutions out there. And so as you can see the grid here, I'm not going to read the whole thing, but from all of these kind of hardware procurement, network and hardware config, software deployment and config, all of these categories, there was a lot of people involved in these things. And being brutally honest, it would take us months to deploy and configure a production instance of these solutions for customers. Obviously, that's going to cost a lot of money for customers. It's going to be complex. It's not going to be easy to change. It's not going to be easy for us to manage for that customer moving forward. But you had a lot of roles of people involved. You had a lot of skill sets just to get this done in a lot of time. As we moved to our cloud native architecture, and this really represents 2 years of work between Wade and I leading the teams to get this done. Now things shifted, as you can see, right? Because you're looking at maybe deployment in a public cloud as a kind of solution. Now there's no hardware procurement. There's no hardware configuration. Most of the deployment things are completely automated. PKI configuration has been totally simplified. Testing and HA is pretty much automated by the environments, as Wade will talk about. That makes it very, very quick to get this done. Very much a dynamic change in the cost structure for the customer, dynamic change in how quickly we can respond to customers' needs. And then the last kind of column we'll look at is, to kind of meet some of those other quadrants where a public cloud may not meet the security posture for that customer. They may not be able to do that. They may have a private cloud instance in a public cloud provider, or they may manage a private cloud themselves, or in an air-gap environment, simply have a cluster installed on a server machine next to the assembly line. In these kinds of systems, now obviously they're responsible for the hardware if they're doing it on their own. If it's still in the cloud provider is. But now you're looking at a little bit more complexity because they're managing this, but not much, right? You're still looking at this kind of deployment being very, very quick, minutes, not months again. And so this is kind of the change as we talk about this and as we look at what's happened culturally and technologically to do this. This is what we went from in that traditional column to in the public and private column to be able to meet customers where they are, deliver a very complex, highly regulated PKI system very, very quickly for these customers. What was driving this for us? We really truly reinvented PKI from architecture on up. And what that means is we've just modernized this whole platform in scope of everything we just talked about. Now it's way more supportable because if we're getting software out to people and creating the infrastructure to deploy very often, very quickly, whole systems that we can do in minutes, now we can support that much better. Industry changes can be rolled out to customers much, much quicker. We can make changes inside of our systems very quick. And we can support that better for customers. This system can scale because now instead of us relying on kind of traditional architecture, putting more servers in and configuring balancers and all these kinds of stuff, now we're relying on containerization. We're relying on Kubernetes. We're relying on core, well-worn path kind of infrastructure to solve those problems for us by architecting our platform to do these things. we can take advantage of that. And so now we no longer have the responsibility of kind of coding up or configuring those things. We can ride upon the architectures to do that for us. That obviously makes it more flexible. So our move to this cloud native architecture with the Digicert One security platform really meant we can solve all four of those customer deployment scenarios. We can now deploy in many, many ways, single code line that we have to support only one code line instead of 4 different products or bespoken products for customers. Just makes it a ton easier for everybody involved to have high quality, very compliant software everywhere. And then because we can deploy into the cloud, we can integrate with those cloud services. So we can deploy this full stack, again, in air-gap environments, a private cloud you manage, or out into public clouds, IBM, AWS, Azure, you kind of pick it, we can deploy there, utilize cloud infrastructure for those deployments. And this is really kind of meeting the customers where they're at. They're asking for these kinds of solutions so that they can reduce the internal costs, the management costs of these solutions, centralize their IT infrastructures and push solutions forward in one way. Ultimately, kind of in another view of this, from a business benefit perspective, all the things we just talked about really drastically reduce support costs for us, right? Instead of having to engineer many solutions to bespoken deployed systems or a very difficult to migrate and manage cluster of systems, we've now got one line to do this, and we can support these things much quicker. Because we can deploy so quickly, because we can ensure high quality of software through CI/CD and DevOps and the things we're doing, we can deliver these products to market much more quickly. We've broken up, and we'll talk about this, how we're approaching the product. And now we can iterate on these things and distribute them and meet the customers where they are and get product features integrated faster than we ever could. And we're on monthly release cycles, and it's just so much more responsive to what customers actually need. Ultimately, this increases our compliance and InfoSec responsiveness. So if we find a CVE, we're alerted to that. If there's a compliance change, because we can move and manage and deploy the software so quickly, we can also remediate some of these security and compliance issues much, much more quicker. This helps us then, obviously, like we talked about, serve new customers and markets because we can get to places we never could. And then ultimately, as Digicert as a whole, this has created our platform for the future. From an architecture perspective, where we're bringing all these products into this and expanding on this architecture to deliver everything to the customers where that customer is. So let's hammer this home for 1 second here before we kind of pass off to Wade, and he tells you the how, because I'm telling you kind of the what and the business benefits. From if we kind of compare and contrast our classical deployment on the left here, that's actually a screenshot from one of those 57 PDFs that kind of talks about the network topography and the systems that need to be deployed. You can see there's many systems, there's databases, firewalls, routers, load balancers, all kinds of things you have to do. So you got to procure all that stuff. You got to buy all that stuff. You got to configure all of those things. You got to get HSMs and put those in there, third-party licenses and management of third-party software and configuration. We generally had professional services people help over the full span of maybe 8 weeks to do these deployments, licensing many things, third-party products and whatnot to get in there. And then from a skill set perspective, again, to get all these things deployed, configured, you need IT, SRE, professional services, some developers, procurement folks. It takes about 2 months to get all of this through and get an installation up and running. It's an amazingly long time to get to the benefits of this system. And again, you got the 3 pictures there because once you did one of those things in the traditional, you had to do a second for HA so you can make those work together and a third for test. So you had to do these things repeatedly. In a modern system, what we're really looking at is now you have, kind of the blue person here, kind of the installation machine, if you want to think of it that way, and Wade will talk about that can deploy to the cloud. And it's that simple. It's automated scripts that can go to any cloud, private, public, wherever, deploy, configure, do everything that's kind of represented in those boxes at the left, but doing it standards-based and doing it with containerization technologies and getting these things deployed. And that means it's very repeatable, very portable. We can go across many different cloud structures, deploy into different architectures. And from a hardware, software, license skill set perspective, Again, drastically reduces what needs to happen there. And generally we can get this configured in under an hour initially, and scaling it or changing it is in seconds afterwards. Whereas previous classical environment changes or things afterwards would scale in months. So it's a very dynamic system. Get it all initially configured, deployed in about an hour, scale it, change it in seconds after that. And because it's very dynamic based off these infrastructures, it can horizontally scale on its own, horizontally scale as you dictate that it wants, you want it to, and allows these kind of changes to happen very dynamically. And that helps us meet these markets in places we couldn't before. So Wade, at this point, I'm sure everybody's kind of thinking about the how and what it means. So if you could, can you jump into some of the aspects here of what's going on?
Yes, thanks, Brian. Yeah, I think you summed that up very nicely and described the problem. And I'd say as we began our journey to reduce the time it took to deploy our world-class PKI solution, Digicert One, we looked at our processes and our engineering culture. And instead of taking months to deploy our solutions, we definitely had the goal to get that down to minutes. We knew we had to think differently about how we built and deployed our code. Our engineering processes and our system designs didn't cut it at the time. I'm going to discuss our mind shift from a traditional n-tiered web service architecture to a cloud-native architecture, and how this helped achieve our goal of reducing our deployment times. So on the left side, I'm kind of comparing and contrasting where we were before we got into a DevOps culture and where things now. So kind of the benefits of then and now. So you can say the left side is where we were then, and on the right side is where we are now. And I think early on, it was fair to say that we designed code for the development environment and not production. After the code was tested and some manual tests and automated tests were run, we threw our code over the wall to our IT operations team, and they would have to deploy a large number of changes and features into productions. Oftentimes, these production servers were specialized and had very specific sets of libraries and configuration files they needed to change. Each new deployment could require careful configuration changes. Needless to say, deployments were large events that could take hours of downtime. We needed developers and operation teams to work together to solve the headaches of this deployment. It was essential to have communication between each team to design a system that was built for production and not the developers' laptops. Instead of specialized virtual machines in production, the runtime environment needed to be part of the development process. And the solution to that problem was containers. If we look at the evolution of the data center over our career, some of us, like myself, I remember early on, installed applications on dedicated servers. So with each addition of an application in the data center, we had to order and install and rack that hardware to run our application. Not only did this take a number of weeks to purchase and set up the hardware, it was very inefficient. The applications only used a fraction of the computing power of the system. Virtual machines helped reduce the waste. A single physical machine could host a number of virtual instances of an application server. However, there still was waste. Each virtual machine had to have a full operating system installed. So a large percentage of the host machine's resources were used to run the operating system and not the applications. So containers eliminated the efficiencies of virtual machines. Containers have many of the same benefits of virtual machines by isolating and subdividing the resources of a server, but with one big difference. Containers don't require a full operating system. They share services with the host and therefore have a lighter footprint and can spin up in no time. Each physical server can have dozens of containers running on it with a fraction of the resource utilization. Docker is the primary provider of container services and solutions. The runtime environment, the configurations, and services can be packaged together. The same environment used to deploy the service is deployed in production. It reduces worked on my laptop errors and generally increases the quality of the product. It also speeds up deployment time. No need to make manual configuration changes in production.
Just to kind of comment on that, I think this is one of the places where, as we've worked with our professional service and SE group, and even customers, as we're talking with them, maybe from the change of the old platform to this one, or net new customers with what our architecture is, I think this is where there's a big point of confusion for folks, right? Between, what's the difference with a virtual machine and a container, or why are you using containers instead of bare metal? So do you want to maybe comment on that for a second? Because I know that's something that we get into all the time.
Just in terms of what the difference between a physical machine is?
Yeah,
Or,
kind of as we talk about, that difference between virtualization and containers, let's say, because that comes up with customers often. Maybe just kind of address that for a second.
as we were pointing out, the virtual machine still requires the whole operating system to run. And so when you're creating a virtual machine, you're creating a complete instance of a full operating system and an application stack. And the real difference with a container is that, for example, in Linux, you're not spinning up a whole new version of Linux on top of a Linux OS. You're sharing the resources of the Linux machine, and so there's really no overhead to running a Docker container. But you do, like I said, get some of the same benefits that the applications are isolated and running in their own namespaces.
The summary: the customer shouldn't be scared of that. It's really helping them get better resource utilization out of the system.
Yeah, it's an extremely efficient use of server resources, and you don't have to worry about. I mean, you can look at it as a big cost savings.
Yeah. Thanks.
Less memory, less hardware to run. And so as we're talking about containerization, one of the main important aspects of that is as applications grow, especially with a service-based architecture, there's going to be multiple containers required to run your application. And so a container orchestration system such as Kubernetes is very important to manage the deployment and interaction of all these services. I would say Kubernetes is the engine of cloud native architecture. It enables all the benefits that Brian spoke about earlier. It makes cloud architecture and cloud applications very easy to manage with the benefits of scalability, flexibility, easy to deploy. So let's dive into some of the details of how Kubernetes works. Kubernetes is installed on multiple nodes. These nodes can be physical machines or virtual machines capable of running with an OS capable of running the container engine, such as Docker. All the nodes in a cluster work together to eliminate single points of failure. It's a highly available cluster. And this is where we get the benefits of high availability built on top of Kubernetes. The master node on the left-hand side there runs the client-facing APIs for the Kubernetes cluster. So all jobs like deploying applications, deploying new features, deploying containers, and the orchestration of those containers is managed by this node with the scheduler and controller manager. On the worker nodes, the foundation of these nodes is the pod. The pod you can think of as like a logical host, maybe like a virtual machine, and the pods are responsible for running the application containers. And the container node there is just a container runtime or container engine such as Docker, but other container runtimes are supported as well. The kubelet is an agent that's installed on each node, and it's responsible for making sure all the nodes are deployed properly, all the containers and applications are running properly on those. So it does things like self-healing and some of the service discovery and the cool features of Kubernetes. And then the network proxy there with the internet pointing to it is that's how all the network traffic is routed to your system. That's to handle load balancing and network services. So we'll dive more into how to install applications such as Digicert 1 with Kubernetes later on.
Yeah, let me add to that for 1 second, Wade. I think what's exciting about this when I see this chart is it's kind of a summary of a lot of the physical activities that maybe IT or SRE were doing in our traditional deployments of making things work together and deploying things and configuring them. Here within the standards that are embodied in Kubernetes, you can capture those things as a script. You can really up-level it to a standardized way to configure, to deploy, and make these things work together. Removes all of those manual components, removes all those kind of physical touches of systems, makes it very consistent. I think it's one of the truly magical components of what's changed here.
Yeah, it really is. This is when you talk about easy to scale, push button scalability or scaling in seconds, this cluster, the Kubernetes system, is what makes that possible.
Yeah.
The next thing to jump into is the services architecture. So containers had the benefit of enabling a service-based architecture, a microservices architecture, along with Kubernetes. So one of the main benefits of this architecture is that a single service can run in a container. The services are independent and can scale horizontally relative to the other services with just a click of a button with Kubernetes. These will give the application performance where it needs without scaling up less used services. So another cost efficiency, resource utilization efficiency. Also, this architecture isolates change and makes the overall application more stable. One service can be updated without disrupting other services. This is a key component of allowing rapid delivery of features without expensive downtime. Since the architecture is designed to run in a containerized environment, there are flexible deployment options, as you talked about. This is where it makes it easy with a service architecture. It's easy to deploy on-prem, in your data center, or in a public cloud. The next thing to jump into is and tie this all together. So we have all the we have all the tools and processes and architecture in one place to automate the entire deployment pipeline. The continuous integration and continuous delivery pipeline pulls everything together in an automated fashion. This increases the overall quality and speed at which new features can be delivered. CI/CD is all about speed. This pipeline enables us to rapidly develop, package, and deploy containers with the latest features and patches. So gone are the days of months-long release cycles. And on the next slide, I'll jump into an example of how our release process works with Digicert One. So every feature starts with a user story. And so this kind of gets into the process. CI/CD is just as much about process as it is about tools. And we have, once we have a user story defined, we can create a feature branch in our Git repository that represents that story and the tasks related to that feature. So when a feature is completed, a developer will create a pull request, and this kicks off the code review process. And so this is where other developers and QA engineers will look at that pull request, make sure it meets our definition of done. The feature was designed to specification, and it has all the testing automation that we want done. Because the next step is, before we merge it to master, we run a suite of automated tests. This keeps the code quality high. We're trying to eliminate introducing regression bugs or problems into our master branch. We want to keep that as pristine as possible. So if all the tests pass, the code is actually merged into production or into the master branch, and that's where a suite of Docker containers are created and put into our internal Docker repository. And those Docker images are automatically deployed to our stage, QA, and local environments. So all the latest services are available on stage, and that's where you can see all the different Scrum teams and their work coming together in one environment. So when all the stories are completed for a feature at a defined release cycle, we promote those Docker containers to our public Docker registry. And this is where it now becomes available to be deployed on our production environment and available for any of our customers who have it installed on-prem to download it and use it in their environment. And this all happens with simple installation commands that we'll get into later.
Yeah, and this kind of ties back to the point where I was saying that we can be responsive to security and compliance changes, right? When we do have some kind of vulnerability, CVE or something reported, or compliance change, this allows us to very rapidly get those promoted to all parties that are using these systems. Now, the air gap systems, obviously there's some extra steps to get there, but outside of those folks, it's pretty seamless for everybody to stay on the same path and remain compliant and secure.
Yeah, even in an air gap scenario, it's as simple as downloading those Docker images and moving them into your air gapped environment. So there's still it's a very nice packaged product, whether you're doing it through an online script or downloading them and moving them into an offline network.
That's right.
So kind of tying this all together, what we just discussed is the main principles of a cloud native architecture. Cloud native, it's not just a process, it's not just tools. There's building the right culture with DevOps and having the correct communication channels and having the right mindset of automating everything is important. The service-based architecture and leveraging the benefits of containerization to have independently scalable services that are API driven is very critical, and all of these features are kind of pulled together with your CI/CD pipeline that automates everything. Now that you've seen the basics of a cloud native architecture, let's see how our modern PKI platform, Digicert One, can be installed in minutes.
All right, thanks, Wade. So yeah, let's jump to the video. We kind of, in full disclosure here, we've recorded some whiteboard sessions to put into this webinar. So you're going to see past Wade. Now you're dealing with the present Wade. And he's going to tell you about how all of these principles apply to Digicert One as a deployment and walk you through that in some detail. So let's go to the video now.
Digicert One can be installed in months versus minutes. Our modern PKI platform was engineered for the cloud. Before starting, let's assume you have access to a Kubernetes cluster. This cluster can either be in your data center, or it can be a platform on a cloud provider. Additionally, this cluster will need access to an email server, a database service, and an HSM. Although the HSM is not required for initial setup, it can be added at a later time. Let's give a brief overview of the Kubernetes system. What is Kubernetes? Kubernetes is a container orchestration system installed on a collection of master and worker nodes. Generally, these nodes are Linux virtual machines capable of running a Docker engine. These services work in a unified platform to simplify the management of containerized applications. We had the goal to build a flexible system that was easy to scale and highly available. That is why we chose to build Digicert One on Kubernetes. With simple commands, Kubernetes can automate the rollout of new features, secrets and configuration management, service discovery, network load balancing, and self-healing of failed services. In short, Kubernetes is a tool necessary to deploy, install, and run cloud-native applications, such as our Digicert One modern platform. To install Digicert One, you need to install and download a few tools on a deployment machine. This machine can be a laptop or any system that has network access to your Kubernetes cluster. All these tools work on Mac, Windows, or Linux. So the first thing we need to do is install the Kubernetes command line tool on the deployment machine, or kubectl for short. kubectl is the main way you interact with your Kubernetes cluster. This tool is able to deploy applications, inspect and manage cluster resources, and view logs through command line arguments or declarative YAML files. These management actions are made through authenticated API calls to a master node in your cluster. Kubernetes supports multiple authentication methods, from basic username and password to client-server authentication. So the next thing to install on the deployment machine is Helm. What is it? Helm is a package management system. Most operating systems and programming ecosystems have a package management tool. Linux has Yum, Java has Gradle, and Kubernetes has Helm. It defines the application configuration, container information, and deployment information in a collection of files called Helm charts. Digicert One Docker containers are stored in a Docker registry, and charts are stored in a Digicert Helm chart repository. So the last step is to install the Digicert One configuration management tool, dcon. This tool is responsible for collecting environment information needed during the Digicert One installation. It collects information such as email server configuration strings, database configuration strings, and HSM information. This tool outputs YAML configuration files that will be used by Helm and kubectl during the Digicert One installation. Now we have all the tools installed, let's start by running the installation commands. Run the dcon config command and enter the correct values when prompted. When this tool completes, it will output files used for the Digicert One installation. It is important to store the dcon secrets and dcon deployment values YAML in a secure location. These files can be used to restore your Digicert One system if needed. So the next couple of commands will configure the database and deployment tools for the final installation steps. Start by having your database administrator run the SQL script against your database to create the Digicert One schema. Next, configure the Helm tool to point to the Digicert chart repository. All is left is to run a few simple kubectl and helm commands to configure the Kubernetes cluster and install the Digicert One containers. And now in a matter of minutes, you can use your Digicert One system.
That was awesome. Thank you, Past Wade. You did a great job explaining that. That looked amazing. You know, I think that really should concrete for people what we're talking about here. We really just walked through a deployment of our real system. You can see what's happening very, very quickly there. That we've done things there in minutes that used to literally take us months for a highly secure system, for a highly regulated system, very complex cryptographic based system. So let's kind of tie this together. And this is kind of a discussion here with Wade, you know, just for a couple minutes around some of these principles he brought up with DevOps, CI/CD, containerization, and compliance. You know, internally, right? It's like we're saying, or Wade was saying earlier, there's process components. There's certainly technical components, some changes to how these things are going to work. I think there's cultural transformation in this too. When we, you know, kind of shifted and started going down this DevOps environment, you know, I think there was some interesting things that happened here. You know, from an IT perspective, you know, there was some big changes in how things would be deployed and what had to happen. So there was a lot of questions from that team and, you know, how is this going to work and what's my role with these things? From an SRE perspective, you know, it really changed what the activities of that team was doing previously, where, you know, they were kind of, like Wade said, deploying pets, right? You know, systems that needed care and feeding. So now, you know, enabling a system where from a CI/CD perspective, things could be deployed after going through the proper change management processes. That's a big deal. We also had to align product management. And so this was a big thing with aligning what our customers were doing and how they were seeing the market, to how we were delivering software, to how it was actually being produced and being deployed. And that took us some time and some changes to kind of shift things and get that moving and get developers along for that ride and architects along for that ride. And we just kind of had to work out those pieces. And I think, you know, the last thing before I kind of ask Wade to comment on the DevOps note is one of the fundamental things that kept coming out in this process is, you know, what is a air quotes data center in 2020? You know, that for us, we've had physical data centers as Digicert where, you know, we've racked and you know, connected various networks to it and providers and done those things. And now as we've kind of shifted and adopted this environment for our whole infrastructure, right? We're doing this for ourselves. Now we have the ability that when we want to go solve problems like the Netherlands example I was talking about earlier, or different European countries, we can actually go deploy in physical data centers if needed there. We can deploy to cloud instances that are geographically locked on public cloud providers. We can manage the HSMs in our own infrastructure for high security as a hybrid with the cloud. It's really changed the notion of what a data center is and what that looks like for the company. And I think there's a lot of cultural shift that had to come along with that too. So Wade, do you want to maybe expand on that? Did I miss anything?
No, I think you summarized it very well. You know, it really did come down to we had an IT operations group and we had an engineering group, and there was silos, and we needed to break those silos down and enable communication between the teams, and really think of as a deployment as a continuation of the engineering process and not a separate task. That we thought about our end goal of being in production as fast as possible, because we're not really developing, as an engineer, we're not delivering value to an organization until our features are in production. So we had the mindset of you know, DevOps really came down to how fast can we get something in production and get the feedback from our customers that we're doing the right thing, and that we can build an agile organization that iteratively improves our products in the right direction that our customers need us to go.
Yeah, I agree. So kind of shifting to CI/CD, which buckles in nicely with DevOps, you know, I think that there was, you know, development, you know, developer level changes and business changes because now we had this always deliverable software. We never had that before. And you know, the business, I think, changed as we brought the semantic business together with Digicert, that we maybe had, you know, biannual releases from some of the semantic software, or less sometimes, to then kind of moving that process to quarterly. And then now, as we've got this architecture and things together, we've pulled everything to monthly releases. You know, and that makes a business change, right? I mean, sales and professional service and sales engineers, there's the education of what's new, what's coming, how do I use it? There's the documentation that needs to be readily available on a more timely basis, education of how to use those new things, customer education about what's coming. So I think there's a lot of cultural transformation in the fact that we built this thing that could very rapidly deliver software, but we didn't necessarily have an organization that was ready to receive software very rapidly. And so we had to change a lot of things with that too. Do you have anything else to add to that, Wade?
Yeah, I would just say that CI/CD is really the way to automate the processes, the DevOps processes and culture that we built. And in fact, you know, the engineering team is preparing that, or working for the goal that every merge to master in our GitHub workflow is a potentially shippable piece of functionality, and that we can meet the needs of the business wherever they are, and whatever release cycle makes sense. Because if it's a hot fix or a critical patch, we can deploy that in minutes, where that wasn't possible before.
Which I think brings us, you know, from that deployment perspective to the next thing, containerization. You know, I think this was fascinating, right? Because from the business side, I think folks got very excited about what they were seeing in rapid software, and they're like, containers are the solution for everything. You know, so stick it in a container. And I think there was some education that needed to happen there, right? There's some architectures that you could containerize, but they're going to be cloud enabled, right? So that they can be repeatably deployed in a similar way, but not necessarily architected to take advantage of the cloud to scale. One set of things. And then the second set of things was, you know, and the harder one is engineering things to actually be containerized in a manner that takes advantage of a cloud native architecture, so it can take advantage of all the rich features and things that you showed and talked about. And so I think that kind of really came together, where there's a lot of requests and excitement right around this new technology and things that we've been doing, where, you know, executives will say, well, you know, just put that thing in a container, and not really maybe understanding all that goes along with a container, and maybe that's not appropriate thing to be in a container. So I think there's, you know, still education we're working on there. You know, we still kind of see that internally. But I imagine that's probably a battle as we get into the Q&A later, that I'm curious to see what you folks see, if you've had that similar kind of balance and structure in your organizations.
Yeah, certainly you can put anything in a container, even a monolithic architecture, but you don't get any, you're right, you don't get any of the benefits of a cloud-enabled environment, such a cloud-native application. You don't get the scalability of services, and generally those still can be brittle, where you're deploying out an application that's not service-based or microservices architected. You don't get the horizontal scalability of independent services, for example. The architecture with containerization is an important component of a cloud-native architecture. It's not just containers; it is also the way the application is architected.
Yeah, that's great. So the last bullet here is compliance. You know, again, we're in a very regulated industry from a compliance perspective, especially in the public trust area, but we do have other audit criteria for many of the private trust systems and government systems that we run. I think there's a variety of things that kind of fell out of here that I tried to capture a little bit. Pki Operations is a group for us that really has all of the smarts around creating PKI, the roots and the ICAs and revocation management, signing CRLs and stuff like that, offline routes and all that. All of those really detailed bits of PKI, we have groups that do that. Well, this is a big change for them, right? Because initially they were doing things that was all in a physical data center in a room with 14 doors and 700 cameras and whatever the security credentials were around that. And, there's different classes of data, different kinds of customers. There's some customers that are okay with using a cloud HSM for the PKI aspects, and they want maybe dynamic ICAs or dynamic routes that they could create programmatically with an API. That level of security is okay for them. Other customers still want offline ceremonies, and we need to build a system capable of supporting both of those things. And I think for the PKI operations folks that have been protecting the integrity of keys and routes and things for many, many years, this was a big shift for them. And they really needed to kind of figure out, how is this going to work, and how do I segment the activities I need to do with what customers want to do, and where is it appropriate to deep dive. I think the other thing was we have a ton of audits. And in order to do these systems and bring them forward, we kind of need to rethink how those audits work, because an audit is very different when it's in your physical data center, your network you control, and maybe you have cloud-based components, or you have even your own private cloud that you're managing and things in those components. And so I think that took a transformation and change working with those participants to kind of educate them on a lot of the things we've talked about here and how all of this works, to make sure that all of the, the audit and compliant requirements and PKI op compliance requirements could move forward with this architecture. Do you want to add to that, Wade?
Yeah, I really, again, just hitting on the point that the service-based architecture is what allows us to segment these features. We talk a lot about independent scalability, but there's also another great benefit of this architecture, which is that since these services are independent, the services that need this high regulation and to meet these audit requirements can be deployed in separate locations that require those physical controls and those additional controls. And the other services that don't require that, like you were talking about with the private cases, those can be deployed separately and scale separately, because those may have different needs. And so that's really a benefit of not only independent scalability, but also independent use cases and needs of those services that we can deploy separately without constraining the whole system. And so this really does provide us the flexibility that we were looking for.
I think that kind of summarizes some of the things we've seen in the cultural transformation. Again, when we get to the Q&A section, it'd be interesting to talk through what you folks have seen there, because I'm sure there's some similar experiences. Next, what we're going to do is pass this to past Brian. So I recorded a video as well, did a virtual whiteboard and talked about really pulling all this stuff together, right? Where the customers are, where the technology meets them, and how we're gluing these things together. So that's up next. So let's talk about how we use the containerized deployment methodology that Wade was talking about to meet the 4 types of customers we were talking about earlier. First, let's look at the Digicert Managed private cloud customers. These customers are really kind of our historic customers, right? The folks coming to us for web PKI to manage SSL and do these kinds of things. Enterprise customers that are coming to us for completely managed user authentication and network device authentication, those types of customers. These customers, oftentimes, they're looking at using public trust. And for public trust, this is the only way that we're offering it moving forward, right? So we're managing it, we're doing the risk, we're doing the compliance, and all of the other types of workflows will be able to access public trust, but we're managing it, it's never going on site. The other attribute here is automation. So like everything in Digicert One, we want to ensure that customers have a fully automated environment for moving these attributes around and managing certificates. That is just crucial for what people are doing. The last aspect is this is fully managed. And that means Digicert is managing the entire PKI infrastructure, routes, ICAs, everything related to it. Customer has to worry about nothing but utilizing the system. What's magical is the deployment strategy Wade was talking about with the install machine driving the installation of the PKI system. That exact same installation scenario works for every type of customer we're talking about here, every type of deployment. So let's look at the Digicert Managed in-country deployment. So while we're thinking about how Digicert is operating, we have another kind of customer that comes into play. And so we have oftentimes government customers where they're looking for, maybe mid-levels of privacy. You have things where there's standards in regions like qualified certificates in like Europe and areas like that. And with these kinds of deployments, the government doesn't necessarily want to manage the whole PKI. They don't want to deploy these systems, but they want the benefits of PKI inside of their country. And the attributes for these kinds of systems could be things like the keys being geographically in that country, and so never being outside of that region. The data related to these customers sticking in that region. And really, ultimately, because Digicert is managing this, again, there's no customer management required. And so in this way, we're able to take this containerized application, deploy it country by country, and provide these kinds of services with key sovereignty, data protection, and meet the needs of these customers to provide mid-assurance government services. So for customer managed in-country deployment, what we're looking at here is really a customer who is concerned about the people who are managing the system, who has access to the data, who's performing validation, who's doing these services. They're concerned about data and key sovereignty. They want to make sure that data and those keys have the utmost security related to them. And really, they're looking to have their own fully managed environment to give them this high security. And so who are these customers? You're really looking at, again, government customers, but in this case, very high security deployments. And so in these instances, they can manage all of the data. They can do everything on their own infrastructure. Like a government customer, we also have enterprises. And the enterprise customer can use a deployment like this in their own data centers, in their own private cloud, in their public cloud, hybrid systems, but have it fully managed by them where the entire PKI infrastructure is completely under their control. Network, keys, data, everything. That's a customer managed in-country deployment. Last, we're looking at a customer managed in-factory deployment. Now, these are really interesting. These deployments really look at IoT type customers, IoT manufacturers, IoT device manufacturers, the IoT supply chain, the folks that supply chips and processors and secure enclaves into this environment, and then really kind of industrial use case. So these industrial customers, what they have in common is they're typically looking at an air gap environment. They're looking at something completely under their control that is maybe in the factory, next to assembly, assuring very, very high availability. They're looking at things like low latency, where now it's in the factory and there's no network connectivity issues, and they're able to use this very speedy deployment and integration into what they're doing in that factory. You also have multi-party. And so what we mean here is when you look at the supply chain use case, you have PKI that can be distributed through the supply chain with one owner, and the ability to manage those certificates as they're flowing through this whole organization and supplying them in this kind of deployment. Again, with this kind of deployment, we can have these installation machines install this highly scalable PKI, but in this air gap environment. And so it's with this kind of structure that we're really able to take PKI and utilizing this cloud native architecture, allow it to deploy in all these environments. We've reinvented PKI, and with this, we've driven out the cost and complexity of these kinds of systems. We have taken the physical servers and moved them into containers, complex networking infrastructure, moved it into Kubernetes, complex installation instructions, moved it into continuous integration, continuous development, and we've taken a bespoke architecture and turned it into a single repeatable architecture. This is really what's given us the world's most modern PKI and delivers PKI from months to minutes for any customer, regardless of who they are. Thank you, past Brian. This is present Brian. Here now, let's just kind of summarize what we saw there. So we fundamentally reinvented PKI. We took traditional architecture, we took all of the best of breed technology that this company has with decades of experience, pulled that together and created a cloud native architecture that could do all of the things we've talked about. We did this really so we could achieve all of those business benefits that we were talking about, right? The scalability, the time to market, the remediation, and ability to resolve compliance issues. These are rich benefits for us and our customers, right? They can get things more quickly. We did these things, and ultimately this helped us drive out a ton of cost and complexity for both our customers and for ourselves. And that really drives assurance too, right? So customers can be assured of what is coming to them and in timely fashions. And that was hard to do before. This move from physical services to containers and the containerization we talked about was transformational for us and really kind of changed how customers are able to rapidly scale and rapidly use these solutions. I remember the first time more than a year ago now that we installed this system on site for a customer, got it up and running in their Kubernetes infrastructure. And then they said, wow, this is great. But what if I get a bunch of traffic? How can I scale this? And they went through their Kubernetes management interface, and Wade showed them click, click, click. You could just horizontally scale instances of that service, and it just did it. And so they went to being able to manage terabytes of traffic just at the click of a button in a matter of seconds. These things were not possible before, and really kind of demonstrates the power of the system. We moved a lot of complex network and system configurations, like we talked about, to Kubernetes. And so now we've kind of shifted those tasks. We have developers and resources around those deployment plans, codifying that stuff in a very repeatable way into Kubernetes configurations instead of into 57 pages or 57 PDF manuals about how this all works. That helped us move that really complex installation process to CI/CD processes and leveraging that Docker repository for customers, like Wade was saying. And then really fundamentally, we moved a bunch of bespoken products. I mean, they were similar at one point, but as a customer couldn't upgrade for some reason and another one could, they started falling out of sync. Moved all of that to a single architecture that is highly repeatable. And that architecture is deployed by us to offer as a managed service, deployable into that air-gap factory solution or anything in between. And this fundamentally allows us to deliver the world's most advanced PKI platform. But it's this transformation, this cultural transformation, this process transformation and technical transformation to move towards this cloud native architecture that got us to this point. So let's, at this point, Wade, let's open this up to future Wade and Brian, because we're recording this. So even though the videos were past Wade and Brian and we're currently present, this will be past Wade and Brian. We're passing it to future Wade and Brian for the Q&A, where we'll be able to talk with you guys and answer your questions live. So thank you very much. And we look forward to talking to you guys some more. All right. Thank you. So Wade, let's get into some of the Q&A here. Are you dialed in? Can you hear me, Wade? No, still waiting for Wade.
Oh, yep. Sorry, I was working the mute button. Can you hear me now?
There we go. It's what Zoom is like these days. So we've got a bunch of questions in here. How about I'll kind of triage through them and then we can give some answers. Does that sound good?
Sounds good to me.
Perfect. I think the first one is just kind of a note. There were some folks asking if we could share the slide. We absolutely can. So we'll take care of that and getting that to you folks. Appreciate you finding value and asking for the slides. That's awesome. So let's talk about the next question here. So this one is, it says, so scaling still in a local manufacturing unit would still need the classic environment with hardware implementation of HSM at the factory unit? Question. So I think, Wade, they're trying to get at what that deployment looks like in that factory and with an HSM. Do you want to grab that?
Yeah, I think what I'm taking from that is the classic environment, which is the traditional n-tiered web service architecture. No, you wouldn't need all that hardware. What you really need is a cluster of virtual machines if you're going to install it in your own data center. So that could work. Say you're using VMware, you could spin up, 3 or more virtual machines that can host the Kubernetes cluster, and then the Kubernetes system itself will handle all the traditional things like load balancing and all the other things that you would consider in a classic environment. So it's the scaling is different and a lot easier, because with a containerized orchestration system such as Kubernetes, you can literally, with a click of a button or in an automated fashion, scale up more containers in that cluster.
Yeah. Okay. So let's get to the next question here, and I'll take a stab at it to start, and then ask you to give me some backup. The question is, for the HSMs in your solution, so it kind of ties on where you just were, are we able to bring our own HSM, kind of air quotes, to store the signing keys? We want to create additional issuers that are cloud native / cloud agnostic, but their keys must live in an HSM that only we can access through PetAuth or similar quorum. So I think that's a great question. And let me kind of, talk about the HSM integration we've done with this platform. It's one of the defining kind of points that makes the platform really unique. We took very complex interfaces to HSMs, made them very simple and very manageable, and did that in a variety of ways. So, if you want to interact with like an Azure Cloud HSM, which behind the scenes is really a Luna 7, I believe, we can do that, right? And so you can interact with that sort of HSM infrastructure and have somebody manage and host it, of course. But to the point of this, where you want to actually bring your own and store your signing keys, yeah, this solution was absolutely made to do that, right? And there's a couple different ways you can kind of solve that problem. One is if you want to go into your own managed environment, your own kind of private cloud, you can do that and then clearly put your own HSM behind it, although that adds some of the difficulties we talked about earlier. Kind of the next gradation on that is if you went into a cloud deployment, whether it's public or private at like an AWS or something like that. You can also do a direct link from that provider, like AWS calls it direct link, back to your environment and house the HSMs on your own and take care of the privacy in that way. And so there's a couple different deployment kind of patterns, but I think the point is it's pretty flexible. And yeah, you could bring your own HSM, completely control your keys, and take advantage of this architecture. I don't know, Wade, if you had anything else to add to that.
No, you did a really good job. I have nothing else to add there.
Okay, so let's take a look. We got more here. I'm just trying to strip through the questions because there's a bunch. So how about this? So the question is, so does this mean you would set up a Kubernetes cluster in a cloud, AWS or Azure or something, and you would need a cloud HSM to integrate with? So it goes back to what we were just talking about, just to tailor onto that. We could integrate with the cloud HSM. Absolutely, you could go that path, or you could go back to your own physical HSM just to dovetail on that. Okay. Another question here is this solution for those that are still unwilling to trust a managed service? I thought Digicert's push was to extend and enhance the semantic managed PKI that was acquired. And that's a great question. So yeah, we still have the semantic managed PKI, and it's infrastructure that we host and manage and offer to folks. And I hope this kind of got answered in the summary of our presentation as well in that whiteboard session. But the point here was we've changed the architecture, changed the infrastructure, and that same architecture that we have and deployment patterns that we have works across all the different types of deployment options, and that includes us as a managed service provider. So we're using that same infrastructure to get product to people very quickly and very flexibly. The semantic managed PKI platform is actually merging with this environment, right? So a lot of the great features and functionalities you've seen around enterprise use cases or IoT use cases fall into different areas of this product, and a lot of that has already come forward, and more of it is coming through into the next year. And so you'll see those things really come together for you as a customer without disruption. You'll be able to move forward on these platforms. So let's get to the next question here. This one I'm going to throw right over to you, Wade. It is curious about how your design aligns / does not align with newer workload-based architectures like, I'm going to call it SPIFFE, S-P-I-F-F-E. I've never heard of that. Wade?
Yeah, full transparency, I haven't heard of it either until this time, but I did a quick search and found that it was a secure production identity framework for everybody, for everyone. And you know, just basically looking at the overview, it's about securing service-to-service connections. So if you're in a microservices or a service-based system deployed in Kubernetes like we are, it's a way of authenticating the services. And the way we do that is with a JWT token. So every service has an authenticated or assigned token that gets passed to the other services when making authenticated requests. So in that way, as I understand the specification, I would say we are aligned with that.
Awesome. Thank you so much.
With that specification. Yep.
That's great. Okay, so let's jump to another question here. Yeah, so interesting. A lot of stuff around HSMs, but I think this one goes in a different direction too. So, Digicert, which cloud provider are you using for your service, and how are you managing HSMs? So there's a couple different ways we're doing our service. You want to kind of talk about that?
So you're saying which services do we use with our Kubernetes cluster? Or
so which provider are you using for your service? So as we're providing this managed service, which cloud provider are you using, and then how are we managing our HSMs?
Yeah, so we integrate and we've tested our solution with all the major cloud providers, so AWS, Azure, IBM, and as you've talked about before, we can use those HSMs in those environments. We have a number of HSM integrations, and yeah, so it will easily work by using the Kubernetes platforms that are already in those providers' environments. And you can use their cloud HSMs.
Okay. Awesome. Another question we have. We are a VMware shop. Can we still take advantage of something like this?
Absolutely. You know, as we kind of answered on the previous question, really all that's needed as a basis to install this platform is a few VM servers that are spun up, and so that would certainly work with VMware. We recommend having at least 3 servers, virtual machines to install the Kubernetes platform on, and once that's installed, it's just a simple Helm installation script to install our Digicert One containers and run the platform on that system.
Yeah, I think it goes back to the announcement, I think earlier, April, if I remember right, this year, VMware announced support for Kubernetes in vSphere through their VCF platform. So really, it's doing everything Wade said in that infrastructure in the VMware world. Okay, so we got another question that just came in. How does licensing work for the platform? Is it per cert or per connection? So this will be kind of last question we have time for here, but I'll just kind of take this. So licensing in the platform generally is consumption-based, and there's a couple vehicles like things like certs that you can consider. But the product itself, which we really didn't dive into the product too deeply, it's broken up into different managers, different kind of workflows, like an IoT workflow, CI/CD workflow, enterprise authentication workflow. And within there, there's the meters for the kinds of things you would consume in there. That's based off the consumption of what you're doing. So it's really kind of priced next to where you're at and made so you can grow into the product very well. All right,
So with that, I think we're at time, and we've tried to answer all the questions we could here. We appreciate everybody joining us. Thank you for your time. Thanks for taking time out of your day to come and see this. We hope this was helpful. If there are questions we couldn't get to, we'd love to answer them after this. We appreciate everything you guys have brought here with these questions. Wade, did you have anything to add?
No, thanks for everything, and thanks everybody for joining.
Excellent. All right. Bye-bye. Thank you.